Today we're going to be talking about gears, their uses, how they're designed, the different types, and what they do for us and why we need them in relation to automobile and drivelines. So, what is a gear? A gear is a rotating machine. It's a usually round piece of metal with teeth on the outside that transmits torque to another gear when they are splined together. And then the relation of the size of the two gears can alter the output for what we need. If we have large gears driving small gears, we could generate more speed but less torque. Or if we have small gears driving large gears, we can generate more torque but less speed. All this we're going to talk about in a minute when we start talking about ratios. But a gear just transmits torque for us and speed through the different teeth of the gears. Now, in a gear set, you're going to have a driven gear and a drive gear. So if you have a driven gear, that's the gear that is being turned. The drive gear is the one doing the driving. So generally our drive gear is going to be connected to our engine or something that is transmitting torque through it to the driven gear and on down the drive line or to a different component that we need turned by the engine. So we know there are different types of gears. This one happens to be a straight cut gear, or a spur gear, they're sometimes called. If you look here, a straight cut gear is going to have straight teeth here. There's no angle. These teeth are perpendicular to the axis of the gear. So we have a straight cut or spur gear here and here also. The next type of gear we may see would be a helical cut gear, which you see here, the teeth are cut on an angle. And when they spline together with a different gear, let's see if I got two that'll fit together. They're at an angle, but they still spline together and are allowed to turn. Helical cut gears are generally used in transmissions and differentials in a lot of different places because they're much quieter. The tooth design, the way they're beveled here, the way they contact each other, it's a much smoother and quieter transmission of torque. Straight cut gears, when they turn each other, they tend to generate a lot of noise, and generally automotive manufacturers don't like noisy transmissions. So that's why we would use helical cut gears. Then, I didn't have an example of a double helical, but use this as a representation. A double helical, or a herringbone gear, you would have the teeth kind of form this V here, and this would be one piece here. I know the teeth don't match up, they're not the same size, but in a double helical or a herringbone style gear, the teeth would look like this. They would form a V. And then the gear that it would engage with would also have this V style pattern. Another style gear that we see often in drive lines and drivetrains is a bevel. So what we see down in here, it's a little hard to see, but what we have here are bevel gears. And you notice that the teeth on these are kind of in a cone shape. They're laid like this. And these two gears come together and they actually meet at a 90-degree angle. So bevel gears, this is out of a differential, out of a transaxle, are used inside differentials a lot because it transfers the power 90 degrees. So if you have an input shaft coming into your differential, you want to split it out to your wheels. So you need that rotation to split that 90 degrees. Well, with a bevel gear, like a ring and a pinion, that allows us to turn that rotation 90 degrees to get it to the wheels like we need. So those are bevel gears. They're kind of cone shaped. Another type of gear we see are worm gears. And worm gears are going to have a gear that's a little bit longer, and it can be driven by another worm gear, and it's just the design and style of the teeth here. They're much longer, and the gear can be much longer. So you have worm gears, and then also you can have rack and pinion gears. And a rack and pinion gear gives us that ability to change the spinning or rotational motion into a linear side-by-side motion. And you see this mostly in your rack and pinion steering setups, where you have the rotational input from the steering wheel coming into a gear that is now turning the rack, or moving the rack left and right depending on the input. So that turns our rotational movement of our steering wheel into a linear motion of the tires to get us to turn in the direction we want to go. So that's a rack and pinion gear set. Now we also have a internal gear, and an internal gear has the teeth on an inside. This is also called an annulus gear. So if you have your teeth on the inside, it's an internal gear. Now we'll deal with these much more in automatic transmissions than we do anywhere else in a car, because a ring gear or an annulus gear is one of the components that makes up a planetary gear set that we see often in automatic transmissions. So those are the different types of gears that we're going to be dealing with in a car. Some of them you will see more often than others, but that's generally the style of gears that we're going to come across. So let's talk a little bit about gear ratios. Now, I mentioned briefly that if you had a small gear turning a large gear, you would increase the torque but lose speed. And then the opposite, if you have a large gear driving a small gear, you're going to lose torque but you gain a whole lot of speed. And that boils down to the gear ratio. And what a gear ratio is how many turns does the driven gear take when you turn the drive gear. I think I said that right. All right. So if we had one turn of this large gear, we're going to end up with the small gear turning way more than the input gear. So it's going to take the drive gear to the driven gear. I'll get that right. So if we look at a situation where we always take advantage of this increase of torque but loss of speed on a daily, well, take in your transmission also, but one situation where you may have already come across it is in your starter and your flywheel. When you want to start your engine, you crank your starter, turn your key over, and your starter engages, the pinion in the starter engages with the gear around the outside of the flywheel, and it turns the engine over. Well, if you look, we have a relatively small motor, electrical motor here with our starter, but it's still able to turn over an engine. And it could be a V8 or high compression engine that could have require a lot of torque to turn it over. But we don't want large giant starters in there to turn the engine over. So what we take advantage of is gear reduction. And that's when we have the input gear is really tiny. Look at this super little gear here. And this little tiny gear is turning this very large gear that's on the outside of the flywheel. And what that does for us is this gear may be turning really fast, and this gear is going to be turning slower, but the amount of torque we're generating is increased quite a bit. And so it gives this little motor the strength and the power it needs to turn the engine over and fight the compression of the cylinders and all that. So how does it do it? Well, let's think about the actual transfer of motion that we're looking at here. If you look at this small little gear on the starter, it's going to engage the teeth on this flywheel here, on the outside of the flywheel. And if you've ever used a seesaw or used a breaker bar when you're trying to get a large bolt loose, or let's say you got someone over tightened your lug nuts, you got to get out the breaker bar and put a pipe on it and use all that those different tools to help break that bolt loose. Well, what you're doing is you're increasing your torque by getting a mechanical advantage. If you make your tool longer, you're getting a longer lever. And so whenever you push your force against the end of that lever, it's generating more torque at the other end. But think about the amount of movement you're getting. You're getting less movement, but that torque is increased. So that's exactly what we have going on in a gear. This larger gear, if you look at it from, let's say, from the center point here to the outside, think about that as a lever, because this tooth is pressing on this tooth, which is just like you using that breaker bar to break the lug nut loose. So the bigger the gear, the larger the torque advantage you get, the more torque you're generating, but the less movement you're going to get, so less speed output. So with this little input gear from our starter, we're able to turn that engine over relatively easily because of this leverage advantage we get from this large gear that's on the flywheel. Now, this is a rather extreme example of that. This same thing goes on inside transmissions. And if you look here we have a manual transmission, minus its case. Round one. So that's what this manual transmission is for us. It is a series of gears. It's a little too close, isn't it? Just look at the large shot. So what we have in a transmission is a bunch of different gear sets. And all the gears are different sizes and in relation to each other, so that we can get the torque and speed output that we want at any given time. So think about when you're trying to take a car, when you're trying to take off in your car. It's at a standstill, you're not moving forward at all. The engine has to overcome that at rest of the car, right? It takes all the torque it can to just get that car moving, because it's harder to get a car moving than it is to keep it moving once it already is moving. Think about when you're pushing a car from the boneyard into the shop. Getting it going, you have to give it all you got, and everybody's pushing real hard. But once it gets rolling, it's much simpler. It's much easier to move the car. So you kind of slack off a little bit. You can not push as hard, or you can not push at all and just act like you're pushing and let your buddies push the car in. But anyway, that getting it moving is the hardest part. So think about it in a transmission. A manual transmission. Let's say you got a 5-speed transmission. First gear, you're going to need as much torque advantage as you can get. So think about it. The gears in first gear are going to be more like this starter to the ring gear setup. You're going to have a smaller gear driving a larger gear to increase that torque to get that car moving. Now, also when we're at a standstill, we're not moving very fast, right? Obvious. And once you get moving and you need more speed but less torque, then you go ahead and shift up into the next gear, which is going to have a slightly larger input gear to a slightly smaller output gear. And as you go through the gears in your transmissions, those gears are going to get closer to closer in size. Well, when they are exactly the same size, the drive gear is going to turn once, and the driven gear is also going to turn once. And that's what we call direct drive. There's no torque advantage, there's no speed difference, the input and the output are exactly the same. So that's what we call a direct drive situation. But now what if we go past that? What if our drive gear starts to get bigger and our driven gear starts to get smaller? Now our torque is going to be reduced, because think about those levers. We're pushing on that smaller gear. We don't have that mechanical advantage to generate more torque. So we're losing our torque. But now if we have a big gear turning this one doesn't have to turn as much, and the output is going to be increased. The speed is going to go way up. So that's what we call an overdrive situation. And think about it, when you shift into overdrive, you're on the highway, you're already cruising at 60, 70 miles an hour, you hit overdrive, that engine RPM can come down a little bit, and that wheel speed is going to be higher. So overdrive is going to give you a much more efficient highway gear than an underdrive situation, or a gear reduction that we have in all the other gears. Now, modern transmissions, we're adding more and more speeds, right? We're getting 7-speed, 8-speed, 10-speed automatic transmissions even. And what that's doing is giving us more overdrive. And so that's allowing us to have the engine work less, but still get more output speed. So gear ratios are very important and play a large role in how the car drives. So how do we figure it? Now let's back up. We talked about these gear ratios. How do we figure one? Well, a gear ratio, there's a couple different ways we can do it. The most accurate way to do it would be to compare the size of the two gears and do a division problem and come up with your ratio. So instead of trying to measure the size of these two gears, we can just count the teeth. And I've already done it here. I wrote the answer down here. On this large ring gear here, we have 121 teeth. On our starter here, we have only 9 teeth. So if we divide the driven gear amount of teeth by the amount of teeth on the drive gear, we get our gear ratio. And so if we divide 121 teeth by 9, we get 13.4 to 1. And what that's our gear ratio. So this little gear is going to turn 13.4 times for every 1 rotation of the large flywheel here, of the large gear. So that's our ratio. The ratio will boil down to how many times the drive gear will turn versus the driven gear. So there we have 13.4 to 1. So that means we're getting a huge torque advantage, but a very poor speed output. So this thing is to turn 13.4 times just to get 1 revolution. So this is a very large gear reduction. This is giving us a very big torque increase. Now let's think about overdrive. What would an overdrive ratio be? Well, if we had a larger, let's switch this. If we had a larger drive gear and a smaller driven gear, then we're going to be dividing a small number by a larger number. And so we're going to end up with a a ratio that is less than 1, right? So this gear may only turn, let's say, a quarter of a turn, so 0.25, and we already have our 1 turn out of our small gear, right? So that would be an overdrive gear ratio. So these gear ratios and that torque to speed trade-off is what is at the core of a manual transmission. You start off in first gear, you're going to maximize that torque output, but you don't need a lot of speed. Once you get moving, the car's moving, you need a little less torque, a little more speed, you upshift into second gear. So now your ratio's changed to give you less torque multiplication, but more speed output. And so on and so forth. You shift up through those transmission gears, and you keep trading off that torque for more speed. So hopefully that explains things a little bit. The gears and ratios and torque and speed is at the heart of transmission, and how we trade those off and the different sizes of gears to give us the output that we need. So that's all for today, or for this this video. Hope you got something out of it, and I'll see you in the next one.